Welcome back to chemistry class in your home. This is Mrs. Schroeder, and we're going to talk about section 3 in chapter 1 today, talking about how matter is classified. Our objectives today, as you can see, we're going to talk about elements and compounds, how to classify things, how to tell the difference between a mixture and a compound. So starting with matter, some of you have heard the term atoms. You know what an atom is, you think you know what an atom is. Correct definition for it would be the smallest unit of an element that maintains the properties of that element. We'll talk later in the year about what things atoms can be broken up into, because it is composed of other things that make up atoms, but things like electrons and protons, they don't maintain the properties. They have different properties than the element has. Now, all matter is composed of about 110 different types of atoms, different kinds of elements, basically, combined in different ways. So how do we classify matter? All matter is either a pure substance or a mixture. And to kind of show you in a graphic form, if it's matter, which means if it has mass and volume, it's either a pure substance or a mixture. So anything that you see, that you can touch, that you can smell, anything that has mass and has volume is either pure substance or a mixture. So that brings the question of what is a pure substance? Well, it is something that has definite physical and chemical properties. So this is something that always has the same properties. It always has the same boiling point, the same melting point, the same density. It has the same reactivity to oxygen, the same flammability, no matter what. Doesn't matter what size of a piece of this copper I have, it's going to have a certain melting point and a certain reactivity that it's going to have. We do use these properties to identify substances. So I can use something like density of an unknown and figure out what the substance might be. We've talked about that with our density chapter. But pure substances can either be elements or compounds. So what is an element? Something that is on the periodic table. Carbon is an element. We represent it as C. Oxygen is an element. Even though we represent it as O2, it is an element. Aluminum is an element. It's a substance with only a single element involved. Compounds are things that, again, they have definite properties, but it's a combination of different elements. CO2 is carbon dioxide. It has certain properties. It's always a gas at room temperature. You can freeze it and make dry ice at very, very cold temperatures. H2O is a pure substance. This is water. H2O2 is a different substance. It's a pure substance still, but that's hydrogen peroxide because it's a different formula, a different compound. It has different properties then. Mixtures are things that are a combination. When I take two or more substances and I combine them, but not chemically. So I just mix them, basically. Take something and I mix it. The book talks about a glass of sweet tea. You've got the tea, you've got the sweetener, you've got the water. You've got three things in there. Alloys like gold. You've got gold, silver, and copper that make up this alloy. They have to do that because pure gold by itself is too soft. It doesn't make good jewelry. So they add other things to it. Other examples, if you can imagine other examples, Kool-Aid is one I've come up with. Okay, sugar, the packet, the water. Okay, air is a mixture. It's got nitrogen and oxygen in different combinations. Water vapor, carbon dioxide vapor, different things in air. But they're not chemically combined. If I get air cold enough, I can separate the different pieces of air out, the oxygen from the nitrogen. If I wanted to get those separate. So things that are combined, chemically combined, are called mixtures. A couple important notes about mixtures. Composition is not always the same. So some people like their Kool-Aid really sweet, and some people like it not so sweet. So the recipe calls for 1 cup of sugar and 1 packet in a pitcher of water. Now some parents might say, I want to cut back my kid's sugar, and I'm only going to put 3/4 of a cup in there. It's still Kool-Aid. Maybe it doesn't taste quite as sweet, but it's still Kool-Aid. Kid gets a hold of it and says, I'm not letting Mom make it again because she cut my sugar down. I'm putting 1.5 cups in there because it was really weak last time. So now you still have Kool-Aid, but it's got a different composition, different amount of sugar. I've heard people that like to put in 2 packets instead of 1. Maybe they like to mix their flavors or just like a stronger flavor. It's still Kool-Aid. Again, different compositions, not always the same. Another important point about mixtures. Since mixtures are mixed together, not chemically but just physically mixed together, it's something that can be separated by physical properties. So I can use properties like boiling point. That's a physical property. I can use that to separate water and salt. Water boils at 100 degrees Celsius. Salt boils at about 800 degrees Celsius. So it's going to be hotter. So I can get water to 100 degrees, remove all the water, and I'm left with salt. You can use things like particle size. So I can take water and I can pour it through a filter, something like a coffee filter would be an example, to remove the dirt. Dirt is large. Particle size, water is small. Basically single molecules by themselves. Where dirt, they're stuck together. So they're very large. So particle size, again, is something that you can use to separate things with. Okay. At this point, if you were in class, I would have you break into small groups. So since you're not in class, I'm going to break you into groups depending where your rows are. If this is the room as I'm looking at it, over here is my desk. Here's the front of the room. If you are in this set of rows, you're going to look up elements. If you are in the second set of rows, you're going to look up molecules. The third set of rows will be allotropes. Next one will be compounds. Next one will be heterogeneous mixtures. And the last group is going to, if you're on the end here next to the wall, you're going to look up homogeneous mixtures. So what are you planning to look up? Well, there's 3 things. You want the actual definition of it, examples from the book, and then I want you to come up with your own examples. You're going to share these in class tomorrow with your row. So each group, each row is going to get together and talk about what you came up with for your own examples. And I want to see which group has the best of their own examples. So each group will have a chance to finish this chart up, and then everybody's going to have a chance to write down what other groups came up with. So that's basically in a nutshell the whole idea of section 3. Just different properties of materials. We're going to go into some separation techniques and talk about those in class. But that's it for this video. So take your notes, make your summary, and we'll see you in class. Goodbye.